Hello. We're going to look at doubling time using the calculator. All right, so if we look at the first problem, we're looking at 6% compounded annually. And so if I solve this equation, this would be my solution for the number of years it takes to double. In the calculator, what I will do is I will graph the functions and then find the point of intersection. So in order to do this, I'm going to press the Y equal key, and then I'm going to set one side of the equation equal to y1. So I'll make y1 equal to 2,000, the left-hand side. Then I will make y2 equal to the right-hand side. So this is 1,000 times, parentheses, 1 plus the rate, 0.06, and we'll raise that to the x power. X will be our t. Now I'm going to graph this, and so I'm going to set the window. My window for the x, the time in years, will be 0 to 25 years. Most things should double within 25 years. Then if I look at the graph that I'm going to create, the left-hand side, which is 2,000, is really about as high as I need to go. I'll go to 2,800 to be a little bit on the safe side, and then the y-min will be 0. So if I set my window as I have here, then press the graph key, notice here I've got my blue function is the 2,000 mark. The red function is the exponential growth of the account, and what I want to find out is exactly when the red meets the blue or reaches a value of $2,000. So to do this, I find the point of intersection. I'll press second and trace for calculate, then choose option number 5 for intersect. The first curve is the 2,000, that's correct, so I'll press enter. The second curve is the exponential growth on the right-hand side, so press enter. Make a guess, just press enter, and it should lock in. So here I have 11.8956 years. So if I round that, it rounds to 11.90. Well, let's consider compounded monthly. Well, the equation I have to solve doesn't change by much, just this piece right here. So I will go into the y equal screen, and I will change the second function to be 1,000, and in this case, it'll be 0.06. Well, let me do this. Let me clear, because that exponent's going to be a problem. So I'll print the 1,000, and that is times 1 plus the rate of 12%. I'm sorry, 6% still. But it's done monthly, so I will divide by 12 the number of months. And then I will raise that to n times t, that's 12 times the number of years, so let x be the number of years. Now it's important that when you raise it to a power, that if you don't see the power raised like you do on the new calculators, if you use the caret symbol to raise something to a power and it stays on the same line, make sure you put the 12x in parentheses together. And so now that I've done that, I can graph. The window should not change. And so I'll press second, trace, number 5 for calculate. First curve, second curve, third curve. So the third time I press enter, now it says 11.581. So to 2 decimal places, this is 11.58 years. So if it's compounded continuously, let's go back and change our function on the right-hand side. So this will be 1,000. And now it's e raised to the RT, so I'll say second and ln for e to the x. Now I'll just raise it to the RT. The rate is 0.06. We're letting time be represented by x. So now if I graph, find the point of intersection, second, trace, number 5 for intersect. First curve is the 2,000, second curve is the exponential growth, and then the guess. So now It says intersection is 11.552, so that is 11.55 years. So this is how we use the calculator to solve the equation and find the doubling time.